vectors? Are moments vectors? Yes, moments are vectors, because if I have a magnitude of spinning like this, I also have to tell you where I'm spinning. Am I spinning about this axis? I can't do it. Am I spinning about that axis? How is my pen spinning? It has a magnitude of a spin, but it also has a direction of the spin. Is it positive? Is it negative? Right? So a moment is a vector, which means it has a magnitude and it has a direction. Daniel, we're up to you. How do I find the magnitude of the moment? My moment is equal to?
The force, the magnitude of the force times
Magnitude of the force
the
times
distance perpendicular
the
to.
perpendicular magnitude of the perpendicular distance. So this is how I find my magnitude. Eugene, how do I find the direction? Whether it's positive or negative.
The right hand rule.
I use my right hand rule. Okay, so let's look at number 2. So we wanted to find the moment about A. You see how the standard notation, capital M for moment, A sub A is the point I'm going to find the moment about. So I'm trying to find the moment about point A due to this force. So it's the magnitude is 150 times the perpendicular distance. The direction of this force is like this. Everybody look up here. Direction of this force is like that. So that means that the perpendicular distance is going to be right here. This is where my perpendicular distance is. So the magnitude is 150 times 7, and then I use my right hand rule. I put my fingers in the direction of the force. I put my palm towards the point I'm finding the moment about, and I get a positive. So I got a positive 1050 inch-pounds. Then I did the moment about point B. The magnitude is 150 times 7. 150 is the magnitude of the force, times again, the perpendicular distance is right here. It's 7, and I get a 1050, and then I use my right hand rule. Fingers go in the direction of the force, palm goes towards point B, and I get a positive 1050 again. Okay, David, we're up to this one now. In this case, I had this force that was pointing out in this direction. What did I do here? It looks like I solved for the x and y components of it. Why did I do that? Do you remember? Normally, the moment about point A would be equal to the absolute value of the force times the absolute value of the perpendicular distance. But I did not want to do geometry to figure out what that perpendicular distance is.
So you solve for the components.
So instead I solved for the components. I found Fx, and Fx is 86.6 pounds, and Fy was 50 pounds. So the moment, the spin that is occurring about point A is due to this force and this. And after class, I was helping somebody, and I think it helped. Always think of, we talked about a pinwheel. The point I'm finding the moment about, point A, I put my finger here. So what I did with the paper is I stuck my finger here, and the force in the X is going in this direction. So if I took the paper and, okay, put my finger on the point I'm finding the moment about, I take my paper and I move it in the direction of the force. You see how it spins? It spins counterclockwise, which is positive. Finger goes in the direction of the force, palm goes towards my point I'm finding my moment about, it's positive. Again, I put my finger on A, and then I'm trying to pull the force in the Y, and again, it's going to spin that way. Okay, so if it's helpful to actually move the paper, you can. Okay. So in both cases, when I found the moment about point A, Fx created a positive moment, and Fy created a positive moment, and in the end, I have a positive moment about point A. For when I looked at point B,
Why did you multiply 50 by 50? Wait, isn't that supposed to be 5?
5,
Oh, okay. Ooh, alright.
sorry.
That explains a lot.
5, sorry. 5, thank you. Okay, when I tried to find the moment about point B, I took fx again, which is 86.6, multiplied it by the perpendicular distance, because remember, fx goes all the way here. This is the perpendicular distance. So I have 86.6 times 7, positive, and then fy, here's fy, its perpendicular distance is this, which is 10. And I could do this, put my finger on the point I'm finding the moment about, pull my force, and I go in the negative direction, or put my fingers in the direction of the force, palm, towards the point I'm finding the moment about, and I get a negative, and in the end I got 106.2 inch-pounds. So these are the 3 problems that we did the other day. So we took this force, and because we didn't want to find out what the perpendicular distance is, it was quicker, since the distances they gave us were an x and y, we converted this to an x and a y component, and then solved for them individually to find what the total spin was about point A and point B. How about if I wanted to know what that perpendicular distance is? Now that I have the moment, can I find out what the perpendicular distance is? Yeah. Up to Larson? So let's say I wanted to find this perpendicular distance right here to A. If I know what the force and the moment is, can I find it? How would I go about finding it based on the equation we have?
If you know the moment, all you have to do is divide by the magnitude of the force.
Correct. So if we know the moment is equal to the absolute value of the force times the absolute value of the perpendicular distance, we also know that the perpendicular distance is going to be equal to the absolute value of the moment divided by the force. And what was moment A? 856.2, and what was the force? 100 pounds, and it comes out to be what? 8.56 inches, right? How about for MB? The perpendicular distance. Maria, how do I find the perpendicular distance here? So we don't really know. What does this mean here? Not to scale. So it's not drawn to scale. We don't really know. Where does it go? Does it go through B? Is it above B? Is it below B? Let's do the math first and then think about it. How would I calculate?
So we do moment of B.
Right, so it's the moment about B over the force, right? So what is the
106.2.
0.2 divided by 100, and that comes out to be 1.06 inches. Here it was obvious, the force is above, right? But here we don't know. We got a value of 1.06. I'm going to just use this other, I have another picture of it. Yeah. Okay, talk with the person next to you and let me know, is the force above? Is it in position 1? Or is it below? In position 2? Where is that perpendicular distance of 1.06? Is it here? or is it here? So talk with the person next to you. Oh, yeah, next.